Today we will discuss Stanford type arm. It is RRP triple R. This way. This one is x-axis, this one is y-axis, and this one. This is. And it can rotate this way, vertical axis. This joint can rotate this way, having length A2, and here prismatic joint, this one, so it can slide over this. So for this, suppose we want to achieve this point, so first we will rotate θ1, then after displacement, and then after this way. Suppose this is the required point px, py, pz. If we project here this one is px, this one is py. I have drawn in the figure. See, this one is 90 degree angle. If we project this point here, this one is py, this one is px. This length and this length. This length is here this way. This is prismatic joint, and then after this way. So this one is px, py, pz, and this length, and this one px, py. So this is also parallel to this, and if we connect this one is 90 degree angle. I have drawn here. So this is not 90, this one 90. This one is R. So this is px, this is py. So this is R is root of px square plus py square. And this is parallel to this line, but it is at a height of this one. This height. And then after, if the actual point is this, here prismatic joint. So revolute joint, initially this one is revolute joint, this one. Then this one is also revolute. This one prismatic. And after here wrist joint. Though this one, and this one. But we have not shown here. So overall 6 joint. First 2 revolute, third one prismatic, and last 3 wrist joint perpendicular to each other. So observe the figure. Initially this is rotated by this θ1, and then after this axis is rotated in vertical direction θ2, and prismatic joint displaced by d3. This link length is A2. So this one is, suppose this one is D1. This is D1. So parallel to this XY plane, this point is at a height of D1, and then after further advancement in a vertical direction, say S. So this one is 90. So the first joint variable θ1 can be found in similar fashion to the PUMA-type arm. θ1 is arc tan to py by px. Tan 2 is just symbol, inverse function, modified inverse function between minus pi to plus pi. So we have symbolized that arc tan 2 is not multiplier, provided that px and py are not both 0. The variable θ2 is then found from figure 6.6. So initially, suppose we want to achieve this point. So initially we are rotating this way, and then after this one prismatic joint, and then after theta 2, this one theta 2. So this is the reach point px, py, pz. And if we draw here this projection, so it is px square plus py square r square, and this is also parallel to this, so this is r. This one is d1, and suppose this one is s, and this one is 90 degree. So theta 2 is this s by r. So theta 2 is arc tan to SR, S by R. This one is 90. Observe this figure as 3D figure. I have shown here. So theta 1 is arc tan to PYPX, theta 2 is arc tan to S by R, and the Pythagoras theorem R square plus S square. Px here R square is Px square plus Py square, and S is Pz. This one is Pz minus d1. This one is Pz minus d1, it is S. Similarly to the case of the PUMA-type arm, a second solution for theta 1 and theta 2 is given by, if it is in opposite quadrant, then theta 1 is pi plus arc tan to PYPX. Here it is elevated, so in this quadrant it is downward. So theta 2 is pi minus arc tan to SR. The translation distance theta 3, this one, translation distance. This is prismatic joint. So it can slide this way, this way, this way. It is also the symbol is angle, but it is not angle, linear displacement. So translation distance theta 3 is found from the relation theta 3 plus A2 square. Theta 3, this one is theta 3 plus A2 square, equal to by Pythagoras theorem r square plus s square. So theta 3 is root of r square plus s square minus a2, and but r square is px square plus py square, and s is pz minus d1, but square is there, so square minus a2. So we can find theta 1, theta 2, theta 3, and we can achieve certain location using Stanford arm. It is RRP triple R joint robotic arm. Okay, works Stanford arm. So here it is D1, having length D1. It can rotate this way, vertical axis. This one is having length A2. It can rotate in this way, horizontal axis from this. It is prismatic joint, so it can slide this. And suppose we want to achieve this point. It is not at height this, it is above D1. So if we want to achieve this point, so first we rotate up to this point. First we rotate this joint this way. Now this stick having length A2 is parallel to XY plane, but achievable point is here. So if you rotate in horizontal axis in vertical direction this way, theta 2, and then after prismatic joint, so this is the final point px, py, pz. So this one, if you can draw projection here, dot px, py, and if you line draw here parallel to xy plane, then it is r root r square px square plus py square, and this one is s, further advancement. This one is r, so this one is 90, and this one is theta 2. So theta 2 is this one r, and this one s, so opposite side s by r. So it will work like this. Okay.